Now let's see this concept of signed and unsigned numbers. We saw that the largest number that we can represent with n bits is 2 to the 8 or 2 to the n, where n is the number of bits. In this case I'm using 8, which gives you 256 combinations, where my largest number is going to be 255 because I need to account with the 0. And one of the formulas that you can use to find this largest number can be 2 to the n minus 1. And in general, this type of number is what we call unsigned number. It does not have a sign. It's just positive values. There is no way that we can represent negative numbers with an unsigned number. Only positive numbers are allowed. But what if I want to represent negative numbers? Then we need to go to these signed numbers. And let's give another example here. I'm going to use 4 bits. 2 to the 4 gives me 16 combinations, so I can go from 0 to 15 if it's an unsigned number. But if it's a signed number, now I need to use the same 16 combinations to represent positive and negative numbers. So as you probably can expect, my biggest number can no longer be 15 because I need to include negative numbers. In this case, it's going to be a value from minus 8 to 7. So how do you calculate these boundaries? The formula is the largest positive is 2 to the n minus 1 minus 1. Pay attention that this minus 1 is not part of the exponent or the power of the 2, it's outside. And the most negative value is just 2 to the power of n minus 1 and a negative, and the negation of that, or the negative sign. So how do I represent the negative numbers in binary? There are 3 common ways to represent negative numbers. The first one is using the sign bit, second one, 1's complement, and the third one, the 2's complement. Let's go over the sign bit. Let's say that I want to represent the minus 3, and this is the decimal. So from now on, if you see a D, it means that I'm representing these in base 10. In the past, I've been doing something like this, but I can also use a D. So with 4 bits, this is my number in positive number, this is 3. And if I'm using the sign bit, I'm going to change my most significant bit to represent the sign. So that bit is going to represent if I have a positive or negative number. So notice here that because it's a 0, it's a positive 3. And because my most significant bit is 1, this is a negative 3. This is if I'm using the sign bit. When I go to 1's complement, it's slightly different. What you're going to do is you're going to invert each bit. So if you have a 0 becomes a 1, if you have a 1 becomes a 0. So let's go over this example. I have the number minus 3. I write the positive number, which is 3. And now I want to represent the negative number of this. What I do is I flip the bits. Where I have a 1 becomes a 0. Where I have a 0 becomes a 1. And this is the 1's complement. What about the 2's complement? Well, the 2's complement is a step, it has one more step than the 1's complement. You're going to find the first complement and then you're going to add 1 to it. So for example, go back to our minus 3. Negative representation, I'm going to apply the first complement by flipping all the bits. And then I'm going to add 1. And 1 plus 0 gives you a 1. And the rest keeps the same. And this is your negative representation using the 2's complement. There is a shortcut that you can use for the 2's complement, which is instead of using this first complement and then adding 1, you can actually start from your least significant bit until you find the first one and then invert the rest of the bits. So let's go here to our number 3 and I start from my least significant bit, which is this one, until I find my first one, which is exactly this guy. I keep it to 1 and now I flip the rest of the bits. And notice that this answer is exactly the same answer that you got by doing the first complement plus 1. This is just a summary of the 3 different types of representing negative numbers. There are advantages and disadvantages on using any of them. Two's complement is probably a little bit more complex in terms of hardware compared with one's complement, but you can represent a little bit more numbers with this. We'll see it in a minute. And the sign bit is probably like the easiest one, but you are limited on the amount of numbers that you can actually represent. But what it's important to grasp from here is notice that each representation, each number here is different if I'm using a different way of representing that negative number. So I need to tell you how am I representing negative numbers. Otherwise, you don't know how to apply operations so you can get the right values. Here you have the ranges if you apply the sign, 1's complement and 2's complement. And notice that for sign bit you go from -7 to 7 and you repeat the 0 twice. The same thing applies for your 1's complement. It's the same thing, you repeat the 0 over here. So you're losing a little bit of values, but the 2's complement is when you have the full range with no numbers being repeated and you go from -8 to your +7. And that's why probably 2's complement is the one that is widely used in computers.